Our topic for today is all about integration by parts. So we have here the derivation of the formula. It all came from the product rule. So the derivative of u times v, two functions multiplied together, that is equivalent to u dv plus v du. Now if we take the integral of this equation, the right side and then the left side of the equation, we now have the integral of the derivative of u v, that is equivalent to also the integral of u dv plus the integral of v du. Now notice we could cancel the integral and derivative symbol. We now have uv is equivalent to the integral of u dv plus integral of v du. Okay, so let's come to the formula that we will be using here at integration by parts. So we will be using this one, integral of u dv. We'll be transposing integral of v du to the other side of the equation. So we now come to the integral of u dv, and we now have the result uv minus integral of v du. Now this is our formula here at integration by parts. Okay, it is called integration by parts because we are solving an integral by the use of another integral. Okay, so we will be selecting u dv properly in our integrand. Okay, why did we choose u dv instead of v du? Because v du is easy to evaluate. Okay, it is easy to evaluate than our u dv. So our mission is to find u. Based on this formula, we'll be finding u in our integrand, and we will be finding dv. Okay, so there is a guideline in using this formula in selecting u and dv. So we have here the guidelines for integration by parts. Try letting dv the most complicated portion in the integrand that fits the basic integration rule. Then u will be the remaining factor or factors of the integrand. So based on our formula, we need to select or to assign dv and du. dv should be the most complicated portion on the integrand that fits the integration rule. So easy to integrate. Why? Because what shall we do with dv? We will be integrating dv. So the integral of dv, that will become v. Then the u will be the remaining factor of the integrand. Number 2, try letting u be the portion of the integrand whose derivative of a function is simpler than u. So meaning to say, u here should be easy to derive. Why? Because what shall we do with u? We will be deriving the u to find the u. Okay? Now we have to fill in these items. What is the u? What is the dv? What will be the du? What will be the dv? So that we could perform this formula. U times v minus integral of v times du. Note, dv always includes dx of the original integrand. Okay, so this is how we're going to solve items here at integration by parts. And let's have the integral of x e raised to the power of x dx. Most of the student will try to use trial and error method in assigning u and dv. So how many attempts or how many choices can this item or can this integrand be solved. So there is a one possible solution. We have x e raised to the power of x dx. So they would choose x as the u and this one as the dv. Another possible solution or another possible assumption, we have integral of e to the x dx. This one as the u and this one as the dv. Another possible assumption, let's have 1 x e to the x dx. This one as the u and this one as the dv. And the last possible assumptions, we have integral of x e to the x as the u and we have dx as the dv. Okay, so if we recall the guidelines, try letting dv the most complicated portion of the integrand. Is this complicated? No, so this assumption is wrong. This is a complicated, but is it easy to integrate? Okay? So this portion right here is not easy to integrate. So this one is the wrong assumption. Next, how about this too? Try letting u be the portion of the integrand whose derivative of a function is simpler. U is easy to derive. E to the x is also easy to derive. The dv here, this one is easy to integrate and this one is also easy to integrate. So there is two possible option. So if we choose this one, the integral of e to the x times x dx. Let's try this one first. Integral of e to the x dx. We assign u as e to the x. We assign dv as x dx. The derivative of u, that is e to the x dx. The integral of x dx, power rule, x squared over 2. Now notice, we will be applying the formula of the integration by parts, integral of u dv, that is equivalent to uv minus integral of v du. Let's multiply u times v. U times v, we have x squared over 2 e to the x minus integral of v, x squared over 2 times du, e to the x dx. Okay, so we now come to x squared e to the x over 2 minus 1/2 integral of x squared e to the x dx. Notice we have this integral right here, and evaluating this one, it will be another process of integration by parts because we have x squared and we have e to the x dx. So this one right here is the wrong choice in assigning u and dv. Okay, now this one, the integral of x e to the x dx. If we choose u as x, dv as e to the x dx, what is the derivative of u? The derivative of x is dx. What is the integral of e to the x dx? That is again e to the x. Okay, so let's have u times v from the formula. x e to the x minus integral of v e to the x and du dx. So this one is easy to integrate. We now have x e to the x minus integral of this one is again with e to the x and our arbitrary constant c. Now we have the result, this one. Okay, so from what we've learned from the guidelines, dv should be the most complicated but basic in integration rule, easy to integrate. U will be the portion which is easy to derive. Okay, this one. Okay, so based on the guidelines here at integration by parts, we can also come up with this one. Okay, so this one is a guide for us easily assign what could be the u and what could be the db from our integrand. In this particular abbreviation, LIATE, okay, meaning to say we'll assign u for the logarithmic and then the rest will be the dv. We will assign u as the inverse and the rest will be the dv. We'll assign algebraic as the u and the rest will be the dv. We'll assign trigonometric function as the u and the rest will be the dv. And lastly, assign exponential function as the u and the rest will again be the dv. Okay, LIATE stands for log, inverse, algebraic, trigo, exponential. So we will assign this one for the u and the rest of the factor will be the dv. Okay, so let's have examples. Integral of x ln x dx. According to this, we will assign ln x as the u. Okay, so we will not assign x as the u. Why? Because we have to follow the order. If this two is found in our integrand, then we will choose this order. Okay, so let's have the logarithmic ln. So we will assign ln as the u. ln x. The dv will be x and the dx. The derivative of u, the derivative of ln x, that is dx over x. The integral of v dv, which is x dx, it will become x squared over 2, the power rule. Now apply the formula of the integration by parts. This will be equivalent to u times v, x squared over 2 ln of x minus integral of v times du, x squared over 2 times dx over x. We could cancel this one. X squared over 2 ln x minus, we could have the 1/2 outside, x dx. Okay, next we can now integrate this one easily. Let's have x squared over 2 ln x minus 1/2, the integral of this one again with power rule, x squared over 2 plus c. Our final answer will be x squared ln x over 2 minus 1 over 4 x squared plus c. Okay, example number 2. Integral of x cubed e raised to the power of x squared dx. So in this example, look at the order from the LIATE, log, inverse, algebraic, trigo, exponential. We have an exponential and we have also an algebraic. So we will be choosing for the u as the algebraic. So if we assign this one u as x cubed, and what's left, it will become the dv. So if we choose this one x cubed, the dv will be e raised to the power of x squared dx. But unfortunately, it is hard for us to evaluate this one. Why? Because integrating e to the x squared, this is not the du. The derivative of x squared, it's 2x dx. Recall. E raised to the power of x squared, the derivative of that is equivalent to e to the x squared 2x dx. Okay, so we only have dx, we're lacking with 2x. We could easily supply 2. How about for the x? So the first thing that we will do is separate one value of the x from the x cubed. So this would be written as integral of x squared e raised to the power of x squared x dx. Okay, so the u will be x squared, the dv will be e to the x squared x dx. The derivative of u, that is 2x dx. The integral of dv, that is 1 over 2 e raised to the power of x squared. Now let's apply the formula u times v. U, so let's copy this 1/2 first. 1/2 x squared e to the x squared minus integral of v times du. We have 1/2 e to the power of x squared, and we have the 2x dx. 1/2 x squared e to the power of x squared minus 1/2 the integral of e to the x squared, that is 2x dx. The integral of e raised to the power of x squared, quantity 2x dx. This one is equivalent to e to the x squared. 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. This will be our final answer. Okay, for number 3, the integral of x cosine x dx, and we still have our guide right here. We have a trigonometric and we have algebraic, so we will choose for the u the algebraic. So the u is x, and we have trigonometric for the dv. So we have cosine x dx. The derivative of u, that is dx. The integral of dv, integral of cosine, that is sine x. Okay, u times v, that is equivalent to x sine x minus integral of v sine x dx. Okay, this will be equivalent to x sine x minus integral of sine x, that is negative cosine x plus c. So we now have x sine x plus cosine x plus c as our result. Integral of e to the x sine x dx. Again, according to our guide right here, the order should be in this one. We have a trigonometric and we have an exponential function. So we will assign the trigo as the u. U will be sine x. And the dv should be e to the x dx. The derivative of u, the derivative of sine, that is cosine x dx. The integral of e to the x dx, that is again e to the x. U times v, e to the x sine x minus integral of v, e to the x cosine x dx times du. Notice we have a bit of a problem here. Why? Because we still have the exponential and the trigonometric function in this integral. Okay, so just like with our first functions, we have an exponential and a trigonometric. So what shall we do? Again, in this situation, we will be selecting the u and the dv. So if we select cosine x as the u, since it is part in our order, cosine x, the derivative of the u, negative sine x. The derivative of the dv, which is e to the x dx, the integral of that is e to the x. So we will be doing another integration by parts for the portion right here only. So we'll be copying e to the x sine x minus another integration by parts, u times v, e to the x cosine x minus integral of v du. Okay, let's have the negative one, e to the x sine x dx. Okay, so now notice negative times negative, this will become positive. If we distribute the negative to this quantity right here, e to the x sine x minus e to the x cosine x, this will be negative integral of e to the x sine x dx. Notice again here we still have a problem because we still have the exponential and the trigonometric functions, but apparently this one is very familiar, that is equivalent to our original functions. So according to the integration by parts, integral of u dv, uv minus integral of v du. This is an equation, so meaning to say we still have our uv right here. Integral of e to the x sine x dx. If this is an equation, we could transpose this one. Transpose this one to the other side. We now have integral of e to the x sine x dx plus integral of e to the x sine x dx, equivalent to e to the x sine x minus e to the x cosine x plus c. We could add the two integrals because they have the same terms inside. So this will be 2 integral of e to the x sine x dx. E to the x sine x minus e to the x cosine x plus c. Dividing both sides with 2. Okay? So the final answer will be integral of e to the x sine x dx, as this 2 will be splitted to all our terms for the numerator. 1/2 e to the x sine x minus 1/2 e to the x cosine x. C over 2 will be C as our final answer. Okay, so this is the technique in solving integration by parts involving trigonometric and exponential functions. So we now have ln squared x dx. Obviously, we only have one function, ln squared x, and we have the derivative dx. So we will assign this one as the u, ln squared x, or this could be written as ln x raised to 2. And obviously the dv is this one, the dx. The derivative of the u, power rule, we put 2 ln x. The derivative of ln x, dx over x. And we have right here the integral of dv, that is v. So the integral of dx, that is x. U times v, x ln squared x minus integral of v and the du, v x 2 ln x dx over x. We could cancel the x ln squared x minus, we could write the 2 in front of the integral symbol, integral of ln x dx. Okay, so we will be evaluating this one again via integration by parts because there's no direct integral of this one. So we will be choosing again this one as the u, ln x, and this one as the dv. The derivative of u, dx over x. The dv is the dx, the integral of dv, that will be v, and this will be x. So we now come to x ln squared x minus 2. The integral of this portion right here, that is via by parts, u times v, x ln x minus integral of v times du, dx over x. Cancel. We now have x ln squared x minus 2 x ln x minus integral of dx, that is x. Let's see. Final answer will be x ln squared x minus, distributing the negative 2, minus 2x ln x plus 2x plus c. Number 6, integral of x squared e to the x dx. So we will choose again the algebra for the u, x squared, and for the dv we have e to the x dx according to LIATE. The derivative of u, 2x dx. The integral of v, e to the x dx, that is e to the x. Applying u times v, x squared e to the x minus integral of v, e to the x, and multiplied with the du, 2x dx. We now have x squared e to the x minus, let's write the 2 outside, integral of x e to the x dx. Look what we have here. We still have the algebraic and we still have the exponential, but notice the algebraic has decreased its power from x squared. Now it is x. So we have assigned the proper u and du. So again, this is an integration by parts. So let's have the u as x, the dv as e to the x dx. The derivative of u, which is dx, the integral of v, which is e to the x. We have x squared e to the x minus 2. Evaluating this one will be the integration by parts of u times v, x e to the x minus integral of v e to the x and du dx. We could now evaluate this one easily. X squared e to the x, distributing, negative 2x e to the x. Okay, how about this one? Positive 2 integral of e to the x dx. The integral of e to the x dx, that is e to the x. And our plus c, of course. This will be our final answer. Okay, let's solve number 7. Integral of x second squared x dx. Again, we will assign this one as the u from the LIATE. So algebraic first before trigonometric. U as x, the dv as second squared x dx. The derivative of u, the derivative of x is dx. The integral of v, integral of second, that is tangent x. U times v, x tangent x minus integral of v du, tangent x times dx. Integral of tangent x dx from our previous video is equivalent to ln second. This will be x tangent x minus this one, that is ln second x plus c. Okay, this will be our final answer. Number 8, integral of ln x plus 2 dx. The u is obviously ln x plus 2. There are no other functions. And the dv is dx. The derivative of u, x plus 2 dx. Okay? And the integral of v, the integral of dv, this will be equivalent to x. Okay? So we now have u times v, x ln x plus 2 minus integral of v, and we have the du. Okay, we will be dividing this one. Long method. X plus 2 divided with x, we have 1. x, subtract, I have 2 plus 2 over x. Okay, so replacing this one with this one, x ln x plus 2 minus 1 plus 2 over x dx. So we now have x ln of x plus 2 minus distributing dx minus 2 dx over x. We now have x ln x plus 2 minus integral of dx is x minus 2 integral of dx over x, that is ln x plus c. Our final answer. Okay, let's evaluate the integral of x cubed dx whole over with the square root of 1 minus x squared. Now, notice if we have 1 minus x squared from the denominator, the numerator, if we assign this one as u from our previous topic, the derivative of x squared, it is negative 2x dx. So again, we will be separating from our numerator x squared and the x dx all over with the square root of 1 minus x squared. Okay, so we assign x squared as the u, the dv, which is x dx over the square root of 1 minus x squared. Okay, solving this one. So we will be needing negative 2. Separate solution. X dx square root of 1 minus x squared. If we choose this one as the u, 1 minus x squared, the du should be negative 2x dx. So we need negative 2. We already have x dx. So negative 2 over negative 2 integral of x dx over with 1 minus x. Writing this one inside, we have negative 1 half integral of negative 2x dx over the square root of 1 minus x squared, negative 1 half. We have du, u raised to the power 1 half. Take the inverse, u raised to the power negative 1 half du. Negative 1 half. Evaluating this one, negative 1 half plus 1, that is 1 half over 1 half. Okay, so we could cancel this one. That is negative square root of the u, 1 minus x squared. Okay, so the dv right here will be negative square root of 1 minus x squared. Derivative of the u, which is 2x dx. Apply the formula, u times v, negative x squared, square root of 1 minus x squared, minus integral of v, and this is the du, minus square root of 1 minus x squared, 2x dx. Okay, so if this is the u, then this is the du according to here, 1 minus x squared, negative 2x dx. So negative x squared, square root of 1 minus x squared, minus integral of u raised to the power of 1 half, and this one is the du. So we now have negative x squared, square root of 1 minus x squared, minus u to the 3 halves over 3 halves plus c. Okay, So now have negative x squared, square root of 1 minus x squared, minus 2/3. The u is 1 minus x squared raised to the power of 3 halves plus c. Our final answer. Okay, so we will choose the u as the r cos 2x, the dv as dx. Derivative of the u, derivative of the r cos. If we recall, the derivative of the r cos x, that is dx over the square root of 1 minus x squared. Okay, so this one, it's the r cos of 2x. This will be equivalent to the square root of 1 minus 4x squared into dx. How about the v, which is x? U times v, x r cos of 2x minus integral of v, x, we have 2 dx over square root of 1 minus 4x squared. Now we now have x r cos 2x minus 2x dx over with the square root of 1 minus 4x squared. If we choose this one as du, 1 minus 4x squared, the du is negative 8x dx. Okay, so if we multiply both sides with negative 4 over negative 4, or if we place this negative inside, we'll be converting this one into plus. We only need 4. Cos 2x, we have positive 4 over 4 integral of negative 2x dx over the square root of 1 minus 4x squared. We now have x r cos 2x plus 1/4 integral of negative 8x dx over the square root of 1 minus 4x squared. Okay, so the form of 1/4 du over the square root of u, or u raised to the power of 1/2. X r cos 2x plus 1/4 integral of u raised to the power of negative 1/2 du. Negative 1/2 plus 1, that is 1/2. X r cos 2x plus 1/4 u raised to 1/2 over 1/2 plus c. Okay, so 1/4 over 1/2, 1/4 whole over 1/2, that is 1/2. X r cos 2x plus 1/2, what is the u? The u is 1 minus 4x squared raised to the power of 1/2 plus c. Our final answer.